as per the problem given, what we have is a parallel plate capacitor, uh, which is having plates separated at a distance small d, and these plates are connected to a battery having a potential of maximum potential which it can supply is V volts through some set of wires and a switch. Uh, the given problem asks you under what circumstances would the capacitance of this capacitor become double its original value. Let's say that value is C, original value. Under what circumstances would it increase to 2 times that value? So we want the new capacitance to be twice of C. And your choices are whether increasing the charge from whatever it has to double its value, or by increasing the potential of this, which is technically saying, as given in the problem, by replacing it with a battery, larger battery, which can supply double that potential, or by reducing the distance. The relation which helps you to answer this is that, one, the capacitance does not really depend on the charge, which is something which it can store, or the potential, because it actually is a constant which relates the charge and the potential for a capacitance. Meaning which that the ratio of charge to potential is actually the capacitance itself. Meaning which that if you double the charge to 2Q, basically if you're doubling this charge to, let's say, so this is a relation, that's a relation Q is equal to CV, that is Q times V is capacitance, and that's a constant. Increasing the charge to double would not increase the capacitance, because that cannot happen in isolation. You would have to increase the potential accordingly as well. So if you're increasing the charge to 2Q, potential needs to be doubled as well. Then only the charge can be increased without impacting anything on the capacitor to maintain the same capacitance. The only circumstances under which that means, and the first choice is not something which we would say as the right answer, neither is the second choice. As you can see, it is independent of both. The ratio itself is capacitance. So what does capacitance depend upon? Capacitance is purely dependent on geometrical factors on which the capacitance is being created from, meaning which one of them is the area of the plate and the other one is the distance between the plates, and that's the relation of capacitance in the case of parallel plate capacitor. So as you can tell, D comes in the denominator, meaning that if you bring the distance down, even with the same potential, it would be able to store highest amount of charge. So bringing this down to, let's say, a value which is half of it would make it 2 times epsilon naught A over D, and this value alone is the capacitance. So the capacitance is actually going to be 2 times the original capacitance. The answer to this is the third choice, where you are saying that if you decrease the distance from D to D2, D by 2, the capacitance should increase.